So let's take a look at this. First of all, you know, there's a whole bunch of noise out in the marketplace about my B12 is better than your B12 because my B12 is methylated. Cut me some slack. Where's the evidence? There is no evidence. Matter of fact, we'll start by just taking the evidence and taking a close look at it. This is a recent study done in Food Science News, goes back a few years, but it says cobalamin coenzyme forms are not likely to be superior to cyano or hydroxycobalamins in hypertension. Now, the coenzyme forms are the methyl cobalamin and the adenosine cobalamin. So anyway, to get a little deeper in here, it says that methylcobalamin, MCBEL, and adenosine methalamin are coenzymes of methionine synthase methylated coenzyme mutase, respectively. Okay, big words, right? Means nothing. It's knowledge. I mean, it's true, but it doesn't mean anything. In the application of the thing, it just says this is where I'm explaining. They're explaining the structural difference of the molecules, not the functional difference of the molecules. Okay. It goes on to say hydroxycobalamin, and cyanocobalamin are frequently used in supplementation. Okay, methylcobalamin and adenosine methalamin have recently emerged as alternative forms to supplements in light of metabolic transformation, which didn't make any sense. Oh, in light of metabolic transformation, I see that slide got changed, of CBL, which would be cyanocobalamin, into cofactor forms. This review discusses the current evidence on efficacy and utility of different cobalamin forms preventing or treating cobalamin deficiency, okay, which is the goal. Conclusion, and this is up like 50 pages. Conclusion, we conclude that supplementing methylcobalamin and adenosylcobalamin is unlikely to be advantageous compared to cyanocobalamin. So all of this noise that's being made out there about why you need mine and how it's going to be so much better for you, there's no evidence. They don't provide any evidence. Matter of fact, the evidence says no. It says, on the other hand, there are obvious advantages to high parenteral doses of hydroxycobalamin when treating errors in cobalamin metabolism. So the only place you see this is if you have these built-in errors of cobalamin metabolism, which will be determined very early after a child is born, and then they have to live with this treatment for the rest of their life. It's like a child who's born with, has to live inside one of those bubbles. It's something that's built into their metabolism. It is like 0.00001% of the population. Tiny amounts of people, but there is this reality where hydroxycobalamin can fulfill something that the others can't. So now let's take a look at this. What is B12? Facts about B12. Vitamin B12, cobalamin, it's the only cobalt ion essential nutrient in the human diet. Cobalt, right? Don't we make bombs out of that or something? No, you can, but that's not what we do with it. This particular case, cobalt is essential. Okay, that's what it looks like. It's a very interesting little molecule. And right at the center of that thing, I don't know how that slide got shifted over there, but right at the center of that thing is, you'll see the CO in the middle. You can't really see it, but in the middle of that's where the cobalt is. Now, reality is that no plant, animal, or fungi can make cobalamin. Okay, we don't make it. The plants we consume don't make it. It's all made by, not even humans, it's all made by very specialized bacteria or single-cell microorganisms called archaea, and they're in the soil. Okay, so when they produce this cobalamin, it's passed up into the plants that the animals eat, or the ones that we eat, and comes up through the food supply that way. It comes to us that way. So nobody has synthesized any cobalamin. It all comes from that source. All cobalamin, whether it's cyano or hydroxyl or methyl, it's all the same stuff. Okay, just different molecules attached to it. Okay. Thus, all cobalamin is natural. There's really no such thing as synthetic cobalamin. Okay. The way we get cobalamin rich, just to give you a little more background, the way we know that there are certain foods that are more abundant in B12, okay, like beef, for example. The reason it's that is because what do beef do? They eat the grass that comes up right out of the soil that has the B12 in it. And because they are ruminators, meaning that their three-chambered stomach, this stuff stays in there for a long time, they tend to concentrate that B12 and push it out into their tissue. That's why beef is a pretty good source of B12. liver and things like that. You don't want to rely on that because it's a very difficult challenge for dealing with all of that fat and other things that are associated with your body. But it's there. But the reason it's there is because of the way the animals consume those foods and how those foods are moved up to the food chain for us. Note, all B12 present in Neolife dietary supplements is the bacterially sourced natural cobalamin form. End of story, okay? End of story. Now, we call it cyanocobalamin, but I'll tell you why. So let's take a little bit of deeper look here. What do we know? Cobalamin is unstable and must be attached to a stabilizer molecule. If you try to take it out of what it's in, it tends to fall apart. That cobalt ion there is very reactive, and that molecule changes very quickly, almost instantaneously. So you have to be careful about how you do that. There are 4 commonly stabilized forms of B12 that are used openly in the dietary supplement and the medical pharmacy marketplace. So the 4 stabilized forms are cyanocobalamin, hydroxycobalamin, methylcobalamin, and adenosylcobalamin. And of these, cyanocobalamin is by far the most stable. So you can see the 4 different molecules. They've all got a little cobalamin thing there. And the molecule is just a little bit different based upon what's in it, what's attached to it to stabilize it. But the molecule in the middle remains the same. This is more than you wanted to know. But. So B12 and digestion and absorption. Now that's what they say, well, okay, well, mine is better. It's going to be more easily absorbed, despite what that article said in the beginning, that there's probably no advantage to it at all. They're going to tell you that theirs is better absorbed for reasons that they won't be able to give you evidence for, but it makes a nice story. Okay. So we ask them for the evidence. So this is what happens. Upon digestion, all forms of B12 release their cobalamin to a transport molecule. So it gets down into your digestive tract as methylcobalamin or cyanocobalamin or whatever. But you don't absorb that. That cobalamin molecule is handed off to a transport molecule, a binding protein called intrinsic factor. And so it gets down in there, and the cobalamin is handed off to intrinsic factor for passage into the bloodstream from the intestine. So again, it really doesn't matter what form it's delivered in, whether it's cyano or methyl or whatever, that gets down there, and that stuff's left behind, and it's passed off to this intrinsic factor, this IF form, which is probably why that piece of evidence at the beginning said there's probably no advantage, because there's probably no advantage. The stuff gets down there. It's all natural to begin. So stuff gets down there, and that thing that they put on there that says, oh, by the way, ours is better because it's this. There's no evidence of that. Matter of fact, the evidence suggests it's not. And when you understand the physiology, it's not. So the arrow is moved on that slide, but I don't know how this stuff happens. Looks good on mine. But cyanocobalamin, hydroxycobalamin, methylcobalamin, and adenosylcobalamin all hand the cobalamin off to the intrinsic factor, which turns it into transcobalamin. And the bottom statement down here says, it is this IF cobalamin complex that is absorbed and converted to transcobalamin, the TC2B12, for utilization in the body. So, this has never really been an issue until somebody decided that they wanted to sell you an alternative form. And if you're going to sell an alternative form, methylcobalamin, for example, is pretty expensive. Well, not by our standards, but by their standards. So they have to try to create a need for this thing. Why would I, as a manufacturer, want to pay more for this raw material? So they try to create a need. So they point to methylcobalamin. And when you look at their research, what you find is that the vast majority of their evidence of benefit is not from dietary supplementation, but from injection. The medical community has been treating pernicious anemia, B12 deficiencies, by injecting it into the fatty tissue of your body for forever and ever and ever. And delivering methylcobalamin, you can deliver cyano if you want, but delivering methylcobalamin that way, it does prove functionality, not because it's methyl, but because it delivers the cobalamin. So that's the evidence base that they use that says our product is functional because look at the evidence, but it's not from a dietary perspective. And the reason that's true is because the methyl has nothing to do with the amount of cobalamin that's actually absorbed. Okay, so a lot of stories out there. This gets really complicated because the people who concoct these stories are really complicated story concoctors. Because they have to have a complicated story to concoct, otherwise they've got nothing to sell. Right? But the evidence base, when you get down into the bottom, I'll tell you what, if cyanocobalamin didn't work to fight off B12 deficiency, we would have known it decades ago because it's the primary mechanism by which the medical community fights off B12 deficiency. And if it wasn't working, they would have known it. Yes.
Thank you, John. Just a follow-up question on that. Yes. Why do these people selling methylcobalamin, why do they say theirs is natural and that our Sion or whatever is synthetic? Why do they even make that? I mean, where are they coming from in saying that?
Well, yeah, it's a good question. There is no real basis for that. Okay, what they do is they look at cobalamin as it exists in stasis, in so on and so forth, and frequently it will appear as methylcobalamin or hydroxycobalamin or adenosylcobalamin or cyanocobalamin. But when you look at the ratio of those things, often the storage form in certain plants is higher in methylcobalamin simply because that bond, creating that methylcobalamin bond, methyl groups are cheap, biochemically cheap, so it's easy for the body to store them that way. But that's all just a ratio of things, but there is no difference.